to go through. Okay, the first two definitions are commutative property of addition and commutative property of multiplication. They're basically the same definition. The difference is one is for adding and one is for multiplying. So the commutative property of addition is the order in which numbers are added does not change the sum. So 2 plus 3 equals 3 plus 2. Okay, so 2 plus 3 is 5 and 3 plus 2 is 5, so that doesn't matter. A plus B equals B plus A. That's just using variables. Doesn't matter which order you add. Okay. The commutative property of multiplication is the same thing. The order in which numbers are multiplied does not change the product. So 2 times 3 would be 6. 3 times 2 would be 6. Okay. A times B is the same thing as B times A. So the order in which we multiply numbers, the order in which we add numbers does not matter. And that's what these properties. I know you guys already know this, but you need to know that there's a property that exists for it. That's the commutative property, commutative properties that allow you to do that. I'm going to move on. If you are still writing them down, please pause. You might have to pause in this video because I can talk faster than most of you can write, and there is a lot of definitions. Okay, so I'm going to go on to the next screen. Okay, again, we don't need the 2.1 in front. The next one is properties and operations. The associative property. The associative property of addition and the associative property of multiplication. The associative property of addition states that the way in which numbers are grouped when added does not change the sum. Again, I'm basically adding the same numbers. So I have 5 plus 8 plus 2 on both sides. 5 plus 8 plus 2 there, 5 plus 8 plus 2. All I'm doing is switching what I'm adding first. And this one, I'm adding those first and getting 13 plus 2, which is 15. And these, I'm adding 8 plus 2 first, which is 10. And I get 5 plus 10, which is 15. So basically, I can rearrange the numbers. And when I'm adding what the associative property does, combined with the commutative property from the last slide, what those allow me to do is to rearrange numbers. So if I were to give you a problem like 43 plus 21 plus 7, you could add the 43 plus the 7 first using associative and commutative properties to rearrange them. And then you could add the 21 at the end. And that would be a much easier problem to do mentally. But the associative property is moving the grouping symbols. Commutative property is actually moving the numbers. Notice in this example, 5, 8, and 2, the order of the numbers does not change. The associative property of multiplication is the same thing. It's just, again, the way in which numbers are grouped. When multiplied does not change the product. So I can do 5 times 8 first and get 40 times 2, which is 80. Or I can do, or I can do 5 times 16 and do the 8 times 2 first, and 5 times 16 is 80. Okay, it does not matter which way I do it. So the associative property and commutative property are used a lot together. They are different though, and you need to know which one is which. The commutative is where you rearrange the numbers. The associative property is where you rearrange the grouping symbols. That's the difference between them. Okay, I'm going to move on to the next slide. If you need to pause it, go ahead. Otherwise, our next slide is going to be coming up. For our next slide, we are going to be talking about the identity properties. And these, I know you're going to look at and make sense. The identity properties are just what keep a number the same. So for adding, when you add 0 to a number, the sum stays the same. For multiplying, when you multiply by 1 to a number, the product is just the number. Okay? So all you're doing for the additive one is, example, 1 plus 0 equals 1. 10 plus 0 equals 10. By adding 0 to a number, it does not change the number itself. And the key of learning this is not so much for the 1 plus 0, 10 plus 0. It's understanding the variable expressions. That a plus 0 is a. Because that's going to become important when we solve equations, understanding and remembering how to simplify when I give you problems like a plus 0 to know that that is a. For multiplicative identity, it's when you multiply 1 to a number. So like 5 times 1 is 5. Again, this one is extremely important to know that 1 times, or a times 1 is a. Another way you'll see this is 1a. A lot of people write 1a down. Well, 1a is just the same thing as a. And again, when we're solving equations and working, you need to remember that 1a equals a. Or the opposite, if I give you an a, when we start working with variables, you need to remember that that means there's a 1 in front of that a. So this part right here is the important part. This one is the one that we need to know. Hey, kind of looks like a face. Got my mouth, I got some eyes here, I got a monocle on that eye, okay, a scar over on this side, all right, never mind on the face, okay, but you need to remember that 1A equals A and A equals 1A. Those become important for you. Okay. Again, I'm going to move on to the next slide, so if you need to pause, go ahead and pause. And our last slide here, get rid of this 2.1, that's from a previous year, is the multiplicative property of 0. And this one is simply this. Anything multiplied by 0 equals 0. Okay? And you guys know this. And again, this becomes helpful if you get a string of problems like this. If I give you 52 times 13 times 11 times 0 times 2. Alright, use your commutative property and associative property to get 0 to the front. Anything times 0 is 0, so your answer is 0. That's where that one becomes important. Again, you got to remember stuff like A times 0 equals 0. We don't use that as much, but that is important to remember because at times I get people who want to multiply or divide by 0, more multiply, and thinking that they're getting rid of the number when in reality they're actually getting rid of the whole thing. So it's good to remember that that equals 0 when you start working with that. And that is all of our properties that we have to go over. Let me just check to make sure that we got them all done. And here's some examples that we could use with this. So mental math, and this is mental math, so these are the examples I could go with. So for our mental math, this problem here, here's a good example where instead of doing 25 times 11 first, I switched it around to do 4 times 25 first. That got 100, and 100 times 11 is 1100. Another example, this one, again, I'm going to switch the numbers around. So that instead of doing 11 plus 8 first, I'm going to do 11 plus 19. And that's going to be 30 plus 8, which is 38. Okay? So mental math, I showed all of my work. You wouldn't have to show it. It's mental math. But the idea is that you are rearranging the numbers to make it easier for you to do in your mind.